Dear students, today we are discussing the steps involved in computing exact system reliability. For that, we consider the structure function of a coherent system. What is structure function of a coherent system? You know that phi of x equal to what is phi of x? Phi of x1 comma etc. x n equal to union. We could write the structure function of the system in terms of minimal path and minimal cuts. So if we consider minimal path structure, so the structure function can be written like this. Suppose there are p number of paths and each path is if at least one of the path is functioning, then we can say that the system will be in functioning state. Okay, so we consider at least one path and we should have the components in the functioning state for each path. Okay, so this is the structure function of the coherent system in terms of minimal paths. Okay, now similarly we can write the structure function in terms of minimal cuts. How can we write that the structure function in terms of minimal cuts? Yeah, that is we have already discussed, that is phi of x1 comma etc xn equal to, that is we should have all the minimal cuts are functioning. So so we can arrange all minimal cuts in series and so we can write like this, some summation j from 1 to, suppose there are k number of cuts, so we should have all the cuts should be in working condition. At the same time, the at least one of the component is functioning in a minimal cut. Okay, so we should have at least one component is in functioning stage in a particular minimal cut. Okay, so that is, so the structure function would be like this. Okay, so this is the minimal path representation, minimal path representation, and this is the minimal cut representation, right? So this is the structure function in terms of minimal path and minimal cut. Suppose that the components are independent, so what will be the reliability of the system? You know, reliability is nothing but expectation of phi of x. So what is reliability? H of p1 comma etc pn, and we are assuming that the components are independent, so h of p1 p2 etc pn should be equal to expectation of phi of x1. That means this is equal to, okay, for where so we can take the expectation inside, so that we can write like this. Okay, we can take the expectation inside, so since these are independent, x's are independent, so this is actually what is this? Reliability of the entire system, coordinate system, in terms of minimal path, if we represent in terms of minimal path vectors. Okay, so this is actually pi. Okay, this is p. So this is the representation for the reliability in terms of minimal path when we discuss the coordinate system structure in terms of minimal path. Similarly, we can write the reliability of the system in terms of minimal cuts. Okay, so what will be the reliability? H of p1 p2, that is equal to expectation of this one, and that is equal to expectation of this one, and we can take the expectation inside. Okay, so what will be the representation. This is the representation. Right? We can take the expectation inside. So this will be this expectation, and again we can substitute the expectation of PI here. So what will be that? Yeah, this will be PI. Okay. So this is the representation for this reliability of the coordinate system in when we consider the entire system in terms of minimal cut, right? So one example is given here in the textbook. That is, you can consider that example, so you will be able to understand the concept in detail. Okay, so let us take a structure function that is uh, like radius system. Okay, there are 5 components: x1, x2, x3, x4, x5. Okay, so 5 components are there. And what is the structure? X1 is series with the x2 union x3. This is available in your book. x4 union x5. Right. So this is the structure function. So we can expand this. What is this? x1 into what is x2 union x3? That is nothing but 1 minus 1 minus 1 minus x2 into 1 minus x3, right? So again we have x2 x4 union x5, that is 1 minus x4 into 1 minus x5. Okay, so this is the expansion. You can put the expansion, or you can expand all the terms, and then you will get the structure function as, what is this? The one will get cancelled, so this will be x2 plus x3 minus x2 x3 x2 x3. And what is this? This is x4 plus x5 minus x4 x5, right? So this is the some simplified form. Again we can simplify this. Okay, what will be the step? That is equal to x1 x2 x4 x1 x2 x4 then plus x1 x2 x5 x1 x2 x5 then minus x1 x2 x4 x5 x1 x2 x4 x5 then plus x1 x3 x4 x1 x3 x4 again plus x1 x3 x5 x1 x3 x5. You can check it, no problem. Minus x1 x3 x4 x5 x1 x3 x4 x5 then minus x1 x2 x3 x4 x1 x2 x3 x4 then minus x1 x2 x3 x5 x1 x2 x3 x5 then minus, not minus, plus x1 x2 x3 x4 x5 x1 x2 x3 x4 x5. So this is the expansion. To find out the probability, reliability, we can apply the expectation operation. So what will be the result? So you know that this is equal to, so h of p1 comma p2 comma p3 comma p4 comma p5, that will be equal to expectation of 5 of x and x, that equal to, we can take the expectation for each and every time. What will be the result? What will be the result? We can put expectation here, expectation here, expectation here. For each and every time we can apply expectation. Since the components are assumed to be independent, we can take the expectation again inside. So what will be the next step? Yeah, you can put expectation to each and every time. So what is the next step? Yeah, we can put expectation, or we can express like this: expectation of product equal to product of expectation. Okay, so this will be the next step. Okay, so what will be the next step? We can uh, what is aspiration of xi? That is actually pi. So what will be the next step? Yeah, we can put p here. This is p2. This is p4. This is p1. Okay, it should be here. It should be here. Okay, then p1, then p2, then p5. Right? This is p1. This is p2. This is p4. This is p5. This is p1. This is p3. This is p4. This is p1. This is p3. This is p5. This is p1. p3. p4. p5. p1. p2. p3. p4. p1. p2. p3. p5. p1. p2. p3. p4. p5. Right. So this is the condition. Okay. So this is the reliability. We reliability in terms of component reliabilities based on the independent assumption. Okay. Now we look at the what is that inclusion exclusion method. So what is inclusion exclusion method? Hmm? You know that if any one of the minimal path is working, the system will be in working. Suppose ER represent the event that rth path is working. So what will be the reliability? Probably that system is working. So that means probably that at least one of the path is working, that is either E1 or E2 or E3 etc. How many paths are there? EP. So if at least one of the, at least one means any one of, or, so instead of or at least we should write union in terms of events. So probability of E1 union, E2 union, E3 union etc. EP. But you know that for the probability calculation, what is that? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, so what will be the result? So we will write probability of E1 union E2, okay, will be equal to probability of E1 plus probability of minus probability of E1 intersection E2. Okay, this is the probability for union of two events. What will be the result for three events? For three events, probability of E1 union E2 union E3 equal to, what will be the result? Probability of E1 plus probability of E2 plus probability of E3 minus probability of E1 E2 minus probability of E1 E3 minus probability of E2 E3 plus probability of E1 E2 E3. So this is the probability of E1 union E2 union E3, that is probability for union of three events. So similarly we can, so look at that. For two event case it is minus, so it is minus. For the three event it will be plus. What will be the analogous equation for four events? So that for four events that will be, next term will be minus term. Okay, so and moreover you know that so what will be the general expression? What will be the general expression? You can put the general expression like this: probability of let us take the notations. Okay, union I equal to 1 to P. Suppose there are P paths. EP. Okay, EP equal to summation. So the first term will be sum. Single probability will be added together. So I equal to 1 to P. So this is analogous result for what is that? Two set case and minus, for two events we should have negative sign. So what will be the expression here? We will have summation, again we will have summation. Okay, there will be two summation. Okay, so I equal to, or I1, we have to take any two events. So 1 less than or equal to I1. I1 is the any number in between 1 and P. I1 1 to P. Okay, and another number I2 that should be less than or equal to P. Okay, you can remove this. So what will be here? Value of E I1 E I2. Okay, now it will be plus. You should have three terms. What will be the terms? What will be terms? We can take some summation. Again we can have another summation. Again we can have another summation. Okay, this is 1 less than or equal to I1. Second is less than I2, than now less than I3. Okay, I3 less than or equal to P. All these numbers should be in between 1 and P. The value of E I1, E I2, E I3. Right. So then it will be minus, etc. What will be the last term? Plus minus 1 raised to what is that? K minus 1 raised to K minus 1, then P minus 1, because we have P number of terms. P minus 1, then what will be that? P1 intersection, P2 intersection, etc. Okay, so this is the general expression for computing probability of union E EI. Okay, so this is a general expression. So let us look at this. When we look at this general expression, look at this expression. So what happens in this case? From this, point H equal to some 0.5 plus 0.6 minus 0.3. Okay, this is actually 0.8. That can be written as less than 0.5 plus 0.6. Okay, so same idea is applied here. So what will be the result? We can put like this, less than or equal to whatever it is. Okay, we can put, what is that? Okay, this is the situation. And now look at this example. Suppose this point H can be written as 0.5 plus 0.6 plus 0.7 minus 0.4 minus 0.5 minus 0.1 plus, I don't know, What is the situation here? Hmm? 0.5 minus, so it should have a point 67. 0.67. Okay. 9 12 നോക്കി 11 11 5 10 11 17 17 4 13 13 5 8 8 2 പോയാൽ 6 6 2 കൂട്ടി 8. Okay, so what is the situation? So this is actually 0.8. Suppose we remove this term. Okay, what happens? This is greater than 0.5 plus 0.6 plus 0.6 minus 0.5 minus 0.2 minus 0.4 minus 0.5 minus 0.2. Okay, so that is actually, this is actually 0.6. Okay, 0.6. So it is greater than 0.6. So we can apply similar argument here, so that we will get, so if you remove this term, so in this case we have removed this one. Okay, so if you remove this term, what will be the, if you remove this term, what will be the inequality? It will be greater than or equal to. Okay, okay, so that will be greater than or. So alternatively we can see that first one is less than or equal to, then greater than or equal to, then next will be less than or equal to. This process can be continued. Suppose we can write it as, this is S1. Okay, suppose this is, this can be written as some, yes. So instead of first term we can write S1 minus S2 plus S3 minus etc. Last minus 1 raised to P minus 1 P minus 1 SP. Okay, so using this, so instead of this summation we write S1 S2 S3, correspondingly we can identify that. Okay, so this can be written like this. So this is less than or equal to, so we can remove all these terms. What will be the next step? We can use 2 times. So what will be the result? We will have greater than or equal to, right? So what will be the next? Next will be less than or equal to. So in this case, there will be 3 times. So and we can continue like this. Okay. What will be the last step? So the last step we should have the inequality. So what is this? Is exactly reliability of the system. So our reliability is less than or it is a bound for reliability. R less than or S1. This is also reliability. At the same time, it is a lower bound. Okay, it is R is greater than S1 minus S2. This is also reliability. At the same time, this is another upper bound. This is upper bound. Okay. So we can continue like this. So we will get some lower bounds. This is upper bound, upper bound. This is lower bound. This is another upper bound. So on we can continue. Okay, so we obtain the lower bound and upper bound for the reliability. Okay, this is reliability. So we obtain lower bound and upper bound for the reliability. This is known as what is that? Inclusion exclusion for inclusion and exclusion method for finding bounds for the reliability. Okay, I think you got the idea of construction of this inclusion exclusion method. Okay, you can write with the help of your textbook, and I have sent in the WhatsApp group. No problem. Okay, if you have any doubt, you can ask me. Okay.